Okay, ma. So this was the question which was given in the last class, no, ma. So velocity of the wave is how much? Velocity of the wave is 2 meter per second. And at x is equal to 0, the pulse is having this much of position at x is equal to 0. So the shape of the pulse is given by, or position of the pulse is given by y is equals to 2 divided by t square plus 1. Clear, ma? So first question is, I want to find out expression of wave pulse as a function of displacement and time. Clear? So this given function, it is just a position of the wave pulse, no, ma? So if I want to express this one in the form of a traveling wave, then how can I write this one? So if I want to write this one in the form of a traveling wave, what is meant by traveling wave, ma? Traveling wave means which is traveling from one place to another place. Then if it is traveling along positive x-axis, then this function should be a function of displacement and time, no? So shape of the wave pulse changes according to, or position of the particle changes according to x value as well as t value. So therefore, for a traveling wave, how can I write? I can write y is equals to 2 divided by t minus x by v whole square plus 1. I can write like this, no? Are you able to understand, ma? Because we know displacement is equals to velocity into time. Therefore, what is time? Time is equals to displacement divided by velocity. So t minus x by v. It means the shape of the pulse will be what? The shape of the pulse will be exactly equal to the shape of the pulse before a time of x by v. So now this becomes the equation of a traveling wave which is traveling from one place to another place. Okay, ma? Now, velocity already he gave, no? If velocity is already given, then how can I write y value? Y is equals to 2 divided by t minus x by 2 whole square plus 1. Okay, so this becomes my equation for a traveling wave pulse. Okay, so this is my answer for the first question. Second question, what he is asking? He is asking shape of the pulse at t is equal to 0 and t is equal to 1 second. Okay, ma? It means I am supposed to draw the graph of this wave pulse. Clear? So how wave pulse will be generally? Wave pulse will be like this, no, ma? This is the shape of a wave pulse. Okay. So therefore, after some time, what will happen to this wave pulse? For example, I can say after some time, this wave pulse may travel up to here. Okay. Previously, the maximum of wave pulse was here. Now the maximum of wave pulse is here. So this is the distance traveled by the wave pulse in a particular time of t. Clear, ma? So draw the shape of wave pulse means what? So at t is equal to 0, you take different positions of x value, and relatedly you find different values of y values. Clear? So for example, you can take x value is 0, find out what is the equation for what is the value of y. Similarly, you take x is equal to plus 2, then you see what is the position, what is the value of y. Similarly, you take x is equal to minus 2, then you check the value of y. Like this, we find out the shape of the wave pulse. Then again, we have to draw another wave pulse after a time of 1 second. Clear, Nama? So calculate both of them and see what is the answer you will get. Okay. So which values shall we take? So next one we are studying about shape of wave pulse. Clear, ma? So you do one thing. What was the equation we have written? The equation is y is equals to 2 divided by t minus x by v whole square plus 1. Clear, ma? So what are the values you are supposed to take? Take x value is 0. Check what is the y value you will get. So take x value is plus 2. You check again what is the value of y. So you take x value is minus 2. Then you check what is the value of y. Clear, ma? x is equal to plus 4, check what is the value of y. X is equal to minus 4, check what is the value of y. Clear, ma? So, when you get x and y values, then you can draw a graph of the pulse number. So, and here at what time we are taking? We are taking at a time of t is equal to 0. Okay. Then second condition, again he is asking us to take t is equal to 1 second. No? There also you do the calculations. Clear? So then I am taking at t is equal to 1 second. Okay, ma? So at t is equal to 1 second, it should have traveled a bit forward, no? So these values, instead of taking these values, you do one thing, take x is equal to 0, then calculate what is y value. X is equal to plus 2, then calculate what is y value. X is equal to plus 4, then again you calculate what is the value of y. Okay. Then draw a graph of this one, draw a graph of this one, that is my required answer. Okay, ma? So, the values which you should get here are, if x is equal to 0, you will get y is equal to 2 centimeter when time is 0. Clear, ma? X is equal to plus 2, you will get y is equal to 1 centimeter. X is equal to minus 2, you will get y is 1 centimeter. Plus 4, 0.4 centimeters. Minus 4, it is 0.4 centimeters. Are you able to understand, ma? So, similarly, at t is equal to 1 second, what are the values he has taken? X is equal to 0, y is equal to 1 centimeter, x is equal to plus 2, 2 centimeters, and x is equal to 4, y is equal to 1 centimeter. Clear, ma? So, these are the respective positions of y with respect to x. Now, just draw a graph of them approximately. That should be your answer. Understood, Nama? So, therefore, how you will get the graph? So, check for this graph, ma, when time is equal to 0. So, when x is 0, y is 2. X is plus 2 and minus 2, y is 1 centimeter. X is plus 4 and minus 4, y is 0.4 centimeter. It means the position of wave pulse is maximum when x is at the origin. No? So therefore, how can I draw a graph? Therefore, graph I can draw like this. So this is the approximate shape of the graph when time is equal to 0. Clear, ma? So here x value is 0. What is y value? Y value is equal to 2 centimeter. Clear? Clear, ma? Then x is equal to plus 2. Plus 2 and x is equal to minus 2. So here what is the position of the graph? Here the position of the graph is approximately 1 centimeter. And when it is at 4, plus 4 and minus 4, here what is
here the displacement is here displacement is 0.4 centimeters. Okay. So therefore here also it is 0.4 centimeters. So therefore at minus 4 also 0.4 centimeter and plus 4 also it is 0.4 centimeters. Okay. So this is the graph which we got. Now let us see graph at a time of 1 second. So here at x is equal to 0, we have y is equal to 1 centimeter. X is equal to 2 centimeters, y is equal to 2 centimeters. So if you observe the graph at t is equal to 0, then y is equal to 2 centimeter at x is equal to 2. Okay. But if you observe t is equal to 0 graph, then we have maximum value at x is equals to 0. So I can draw graph like this. Clear? So here I can see that the maximum value is obtained at x is equal to plus 2. Are you able to understand me? So therefore, in a time of 0 to 2 meters, so the displacement of the graph is also 2 centimeters. Are you able to understand? So therefore we already studied that velocity is equal to 2 meter per second. So therefore in a time of so we have velocity is equal to 2 centimeter per second here. This is already given in the question. Now if I see here in a time of 1 second, so that is from time is equal to 0 to time is equal to 1 second. So can you see how much the waveform has displaced? So because velocity is 2 centimeter per second, so it means in a time of 1 second graph has displaced by 2 centimeters. Clear? So that's it. So here I can see graph has displaced from 0 to plus 2 centimeters. Now let us study about the speed of a traveling wave. So consider this is a wave, then after some time wave will travel forward. Let the displacement of the wave is x. So wave has displaced by a small distance of x here. Okay. Now because wave is traveling with uniform speed, what is the relation I can write? I can write displacement is equals to velocity into time. So instead of displacement I can write wavelength velocity is v, and what is the time taken for one wave to pass? It is called as a time period. So instead of small t I am writing capital T here. Okay. So therefore v is equals to lambda divided by t. So 1 by t can be written as nu. So v is equals to nu into lambda. So this is the equation of a wave which we have already studied. Clear? So because wave is traveling with a uniform speed, we can write v is equals to nu into lambda, which is derived from the relation displacement is equals to velocity into time. So therefore lambda can be written as velocity into time. Now we are dividing this total relation by 2 pi. Okay, ma? So if I divide this total relation by 2 pi, then it is lambda by 2 pi is equals to velocity into time divided by 2 pi. So this is the relation which I got up to here. Okay, so this is lambda. So now the question is that what is meant by lambda by 2 pi in this condition? Okay, already we have studied that k is equals to 2 pi by lambda, so which is called as wave number. This is called as wave number only, no, wave number, or you can call this one as propagation constant also. You can call it as either wave number or you can call it as propagation constant. So k is equals to 2 pi by lambda, but here in the given relation we have lambda by 2 pi normal. So here we have lambda divided by 2 pi. So therefore lambda divided by 2 pi is nothing but 1 by k. So 1 by k is equals to, so velocity into next to 2 pi by t by 2 pi. We have this relation 2 by t pi. No? Already we know that omega is equals to 2 pi by t. So therefore t by 2 pi is nothing but 1 by omega. So therefore 1 by k is equals to velocity into 1 by omega, or velocity by omega. So therefore v is equals to omega divided by k. So this is one more equation to calculate velocity of a wave. Clear now? So one relation already we have studied, which is equals to v is equals to nu lambda. Another equation is velocity is equals to omega divided by k. So this is the velocity in terms of frequency, angular frequency, and propagation constant. Okay, so let us see the next concept of phase constant or initial phase. Okay, so what is the equation of wave we have written? We have written y is equals to a sine omega t minus kx. So this is one equation which we have already written. Same equation I can write y is equals to a sine kx minus omega t also. Okay. So now both these waves, they are representing the waves which are traveling towards positive x-axis only. But why we are writing omega t minus kx and kx minus omega t? What is the difference between them? So that we are going to study now. Okay, so what is the difference between these two waves? So just difference depends upon the reference from which we are observing these two waves. So consider this is one wave, clear now? So this is my first reference from which I am seeing my wave, and that is given by the second wave, y is equals to a sine kx minus omega t. Now if I draw second reference, now this relates to the reference frame from which I am observing. For the first one it is y is equals to a sine kx minus omega t, and for the second reference it is equals to a sine omega t minus kx. Okay, so there is a phase change of 180 degrees between both of them. Now let us try to understand why we are writing waves like this. So let us draw one dotted line. This dotted wave indicates that wave has traveled forward after some time. So if you see the particles, are the particles here, they are moving downwards, and the particles on the other side, they are moving in upward direction. So now this equation y is equals to a sine omega t minus kx, if I differentiate this one with respect to time, then what is the relation I will get? So v is equals to a cos omega t minus kx, clear now? Now I have differentiated only sine function here, but we are differentiating with respect to time now. So if then all the time terms also I have to differentiate. So what is the time term here? Omega t is a time term. So again, if you differentiate this one with respect to time, that is a d by dt of omega t, then I will get omega. So therefore v is equals to a omega cos omega t minus kx. This is the relation which I got. Okay. Now if I see this relation, I got velocity of this wave to be positive number. So I got v is equals to a omega cos omega t minus kx. It means the particles, they have positive velocity. Okay, ma? So positive velocity means which particles are having positive velocity? The particles which are present at reference 1 or reference number 2. At reference number 2, all the particles, they are moving in upward direction. Clear? So that indicates that second reference indicates to the wave y is equals to a sine omega t minus kx. Now if I differentiate the second equation dy by dt, then I will get a sine kx minus omega t, a cos kx minus omega t. Now again, if I differentiate kx minus omega t with respect to time, then I will get minus omega. Okay, ma? So therefore velocity of the wave is minus a omega cos kx minus omega t. This is the relation which I got. Clear? Now if I observe this wave, so this wave is having negative velocity. So we got y is equals to minus a omega cos kx minus omega t. It means all the particles, they are coming downwards. It means definitely my reference frame should have been reference frame number 1. Clear, no? That is my reference frame. So therefore reference frame number 1 indicates to the second equation y is equals to a sine kx minus omega t. Clear, no? But both of them indicates these are the two waves which are traveling towards. So up to here it is clear, Nama. Now let us try to understand what is meant by phase constant or initial phase. So at time t is equal to 0, what is the phase of the particle? That is called as initial phase or phase constant. So let us see this wave. So at this origin, that is at reference 0, 0, particle is present at the main position. Clear, Nama? So here I can write the initial phase of this particle is so much, initial phase of the particle is 0. This is what I can write, because particle is present at the mean position and there is no phase for this particle. So because already we have studied that SHM and wave motion we can compare with circular motion. So now if I take one more wave, so let wave be like this, clear now? So here at t is equal to 0, so definitely particle is not present at the main position. It has already some positive phase which is already present, clear now? So there is some positive phase of pi which is already present. So therefore, for this one, how can I write the equation? I can write y is equals to a sine omega t kx minus omega t plus pi. So this is the relation which I can write, because already there is some positive phase which is present for this particle. So we write y is equals to a sine kx minus omega t plus pi. Clear now? That's it. So therefore, if I take one more wave and if I draw the graph like this, clear? Now what do you understand by looking at this graph? Clear one? So here also at time t is equal to 0, I see that the particle is not present at the main position. It is present at a negative displacement at a time is equal to 0 when I started observation. It means already there is some negative phase present for this particle. Clear number? So therefore for this one the equation which I can write is a sine kx minus omega t minus pi. Clear now? So this is how we can write the equations of waves with respect to the initial phase. So see here, particle, it was present at mean position when time is equal to 0, therefore its initial phase is 0. But in the second condition, already there is some positive phase present in the particle. So that's why we are writing plus pi, and in the second condition there is some negative displacement, we are writing minus pi. Clear now? See my here, phase constant values, they differ in wave motion and simple harmonic motion. So how we define wave motion? We define wave motion by taking a reference to the previous condition. Okay. Okay, so this is the given question. So a wave is traveling along x-axis. So disturbance at x is equal to 0 and t is equal to 0 is a by 2. Clear na? So that is at origin, and at time is equal to 0 means what? That is when we started observation, time is 0. So at that position amplitude is a by 2, and it is increasing with respect to time. Clear na? So that is amplitude is increasing with respect to time. It means that what is the meaning of this one? It means that velocity of this particle is positive. That is what I understand. So if a is equals to, this is the given function, kx minus omega t plus pi, then determine the initial phase. That is the condition. Okay. Now let us see how we can write this one. Y is equals to a sine kx minus omega t plus pi. So what are the conditions he gave? He gave the conditions is amplitude is a by 2 when x is equal to 0 and time is equal to 0. Clear now? So here y is nothing but amplitude number. So therefore substitute instead of y, I can substitute a by 2. So a by 2 is equals to a sine. So k into 0. So is 0 minus omega into 0 plus pi. Because x value and t value, they are already given as 0. Clear number? So therefore kx will become 0, omega t also will become 0. So therefore a by 2 is equals to a sine pi. This is the relation which I got. So a and a gets cancelled. I will get sine pi is equal to 1 by 2. Clear? So therefore sine pi will become 1 by 2 at which condition? Can you say? 30 degrees. Oh. So sine pi will become 30 degrees, 1 by 2 at 30 as well as 150 also. Clear number? So sine pi is 1 by 2 at an angle of 30 degrees also. So even at 150 degrees also it is 1 by 2. Because we know sine 150 can be written as sine 180 minus 30 degrees number. Then I will get sine 30 which is equal to 1 by 2. And because it is in the second quadrant, sine theta is positive in the second quadrant. Okay. So therefore pi values can be 30 also, 150 also. But both phases at the same time is not possible number. So any one of them should be correct. So either 30 degrees should be correct or 150 degrees should be correct. So therefore, which one is correct now? So let us see. Okay. Yes. So see. So now he already gave that 1 by 2 and it is increasing number. So what is the meaning of this one? It means that velocity of the wave is positive. Clear? So if particles are moving in upward direction, for example, if you draw this dotted line, so this is the wave after a time of t, no? So if you observe these particles are coming downwards. But you see the particles on the other side, they are moving upwards. And the particles which are moving upwards, so that particle's velocity I can call it as positive. Clear, ma? So therefore here the particles are coming downwards, some of the particles are moving upwards. So those particles which are moving in upward direction, that is indicated by amplitude is a by 2 and is increasing. Okay. So therefore if I differentiate this equation with respect to time, I will get velocity number, and that velocity should be positive. So let us write down. So dy by dx is equals to v is equals to a sine kx minus omega t plus pi. If you differentiate this one, I will get a cos kx minus omega t plus pi. Now again this kx minus omega t plus pi also I have to differentiate number. Are you able to understand? So therefore I will write, if I differentiate minus omega t by time, then I will get minus omega. So therefore it is minus a omega cos kx minus omega t plus pi. Now what are the values at which we are calculating this one? We are calculating at x is equal to 0 and time is equal to 0. So substitute their values. So v is equals to minus a omega cos kx value is 0, omega t is also 0 plus pi. Clear now? So therefore velocity is equals to minus a omega cos pi. So this is the relation which I got. Clear now? So therefore by looking at this relation, what do you understand? Can you see? Clear now? So we got velocity is equals to minus a omega cos pi number. So what do you understand? It means at x is equal to 0 and time is equal to 0, amplitude is a by 2 and it is increasing. Okay, it means velocity should be positive. But I got equation of velocity to be negative, no? So out of these two values of 30 and 150, which one I have to substitute so that my velocity will become positive? Can you see? Yes, 150 degrees. Because cos 150 is, I will get a negative value. Because cos 150 lies in the second quadrant number, and in the second quadrant cos theta value is negative. So negative of negative will become positive. Clear? So cos 150 negative value, negative of negative I will get positive value. Are you able to understand, Amma? But if you substitute 30 degrees, then what will happen? If you substitute 30 degrees, then my velocity is negative because cos 30 degrees is positive. So therefore my answer must be equal to 150 degrees, because cos 150 will become negative, negative into negative will become positive, so therefore velocity will become positive. Clear now? That's my answer. Now let us see this question. So two sinusoidal waves in a string are defined by this relation and this relation. Okay, so therefore what he is asking phase difference when x is equal to 5 centimeters and at time is equal to 2 centimeters. Clear now? So at a displacement of x is equal to 5 centimeters and time is equal to 2 centimeters. Already we have studied that wave equation depends on two factors, displacement also as well as time also. Now second question is, what is the positive x value from the origin from which the two phases differ by plus or minus pi at t is equal to 2 seconds. Clear now? So first of all we are supposed to calculate a phase difference. Let us see. So phase difference, how can I calculate? Phase difference I can calculate. So two waves are there, so I can write pi 1 minus pi 2. So pi 1 is the phase of first particle, pi 2 is the phase of second particle. Okay. So therefore, what is the phase of the first particle here? Phase of the first particle is 20x minus 32t. Clear number? So phase always depends on two factors. No, it depends on x value also. Similarly, it depends on time also. Already we have studied. Clear? So therefore, particle is, because it is performing simple harmonic motion, the displacement of the particle depends on time also, and because wave is propagating in forward direction, phase depends on x value also. So therefore pi 1 is a 20x minus 32t minus phase of the second particle is a 25x minus 40t. Okay. So therefore if I do this calculation, what I will get? 20x minus 25x, I will get minus 5x, and minus 32t plus 40t is how much? I will get 8t. So this is the initial this is the phase difference between the two waves. So minus 5x plus 8t. Okay. So this is the general relation. Now at a displacement of x is equal to 5 centimeter and time is equal to 2 seconds, if I calculate the phase difference, this is the general relation. So now we are supposed to substitute x is equal to 5 centimeter and time is equal to 2 seconds. So therefore at x is equal to 5 centimeter and time is equal to 2 seconds, if I calculate the phase difference, then what I will get? Delta pi is equals to minus 5 into 5 plus 8 into 2. So 5 5s are 25, minus 25 plus 8 2s are 60. So therefore it is equals to minus 9 radians. Okay, no? So therefore what is my phase difference between the two waves? No? Phase difference between the two waves is 9 radians. Okay, no? Now here we are not concerned about minus symbol, no, because phase difference is difference of phase, only magnitude we are concerned about. So therefore in these two conditions, at x is equal to 5 centimeter and t is equal to 2 seconds, so therefore what is the phase difference? I can write delta pi, magnitude of delta pi is equals to 9 radians. Okay, ma'am? So this is the phase difference between two waves at x is equal to 5 centimeter and t is equal to 2 seconds. Clear now? So as x value changes and time changes, this phase difference also continuously changes. Now what is the second question? What is the positive value of x from the origin for which two phases differ by plus or minus pi at t is equal to 2 seconds. Clear now? So after 2 seconds, what is the phase difference between both of them? That I want to calculate. Clear? Now here the question is, what is meant by plus or minus pi? If phase difference between two waves is plus or minus pi, then both waves, they will interfere destructively. So two waves, already we have studied that in wave optics we have studied. So if phase difference is pi or 3 pi or 5 pi or 7 pi, then two waves will interfere destructively. Okay, ma? Completed up to here, no? Now let us. Okay, ma? So in wave optics, what we have studied, this is the screen. For example, these are the two sources S1 and S2. Clear? Now consider two waves, they are interfering at a point P. So this is the paths traveled by these two waves. So from S1, a source of light, a wave is traveling. From S2 also, a source is traveling. Clear now? Now if you see the path S1 to point P, clear now? So here how many, you can study this one in terms of phase differences as well as path differences also. Clear? So here I can say the path traveled by the first wave is lambda plus lambda by 2, which is equal to 3 lambda by 2. And second wave I can say it is lambda plus lambda, which is equals to lambda plus up to here another lambda, and it is lambda by 2. Clear now? So therefore lambda plus lambda plus lambda by 2. Okay, ma? So 2 lambda plus lambda by 2 is how much? It is equals to 5 lambda divided by 2. Okay, that's it, Nama. So therefore if I do this calculation, it is 5 lambda divided by 2. So this is the path traveled by the second wave. So first wave has traveled a path of 3 lambda by 2. Second one has traveled by a path of 5 lambda by 2. So path difference is how much? 5 lambda by 2 minus 3 lambda by 2. So this is the path difference between both of them. Are you able to understand? So therefore 5 lambda by 2 minus 3 lambda by 2 is how much? It is equals to 2 lambda by 2. It means 1 lambda is extra. Clear? So if 1 lambda is extra, it means both the waves, they will interfere constructively, no? That's what we have discussed in wave optics, no? So to here 1 lambda, clear, ma? Which has a phase difference of 2 pi, and from here to here another lambda which has again a phase of 2 pi, and for another trough it is pi. So therefore the total phase of the second wave is 5 pi. Similarly in the second wave, from here to here it is 2 pi, and for the next trough it is pi. So total phase here is 3 pi. Clear, no? Now what is the phase difference between them? Phase difference is 5 pi minus 3 pi is equals to 2 pi. That is the phase. Okay. Now for a phase of 2 pi, already we have studied that two waves will interfere constructively if a phase difference between them is 2 pi, 4 pi, 6 pi, so like this. Okay, ma? So based on this concept only we are doing this problem now. Okay, so first wave, phase difference, phase of the first wave is how much? Phase of the first wave is 2 pi plus pi 3 pi, and phase of the second wave is 5 pi. Clear, number? So there is a phase difference of 2 pi. So for a phase difference of 2 pi, definitely for 2 pi, 4 pi, 6 pi, 8 pi, so definitely the two waves will interfere constructively. This is what we have studied. Clear, Nama? That's what we have studied in wave optics, no? Similarly, for a path difference of lambda 0, lambda 2 lambda, 3 lambda and 4 lambda, so for this one also the waves will interfere constructively. This is what we have studied previously. Clear, Nama? Similarly, if I study in terms of phase difference, then it is 0, 2 pi, 4 pi, 6 pi. For this one also the waves will interfere constructively. Okay, so this is what we have studied in wave optics. Now in which condition waves will interfere destructively? For a path difference of lambda by 2, 3 lambda by 2, 5 lambda by 2, for this one we will get a destructive interference. Clear, Nama? Similarly, instead of phase difference also I can say when phase difference is pi, 3 pi, 5 pi, 7 pi, for these values the waves will interfere destructively. Okay, so therefore there should be one half wave extra, or that is in terms of phase difference I can say pi should be extra, then only the two waves they will interfere destructively. Clear, ma? So therefore for a phase difference of n into 2 pi plus pi, okay, ma? So I will get a destructive interference. This is already we have studied. Okay, ma? It means for both the waves the phase difference should be how much? It should be pi, or 2 pi plus pi, or 2 pi plus 2 pi plus pi. So definitely 1 pi should be extra, then I will get a destructive interference. Are you able to understand now? So that's what we have studied in the last class. So therefore now what can I do? So therefore equate this n plus 2 pi plus pi to the general equation of phase difference which I got, which is equals to minus 5x plus 8t. Okay, ma? And time already he gave. Okay, so what is the time he gave? He gave time is equals to after 2 seconds. So that is after my study of motion, after 2 seconds, n plus 2 pi plus pi should be equal to the phase difference general relation, which is equals to minus 5x plus 8t. Okay, ma? So therefore n plus 2 pi plus pi, so that is after a phase of n plus 2 pi, that is for a phase difference of n plus 2 pi plus pi. So what should be my phase difference? General relation already we have calculated, number. So minus 5x plus 8t. Okay, so let us equate both of them. So I will write, therefore phase difference between both of them should be n plus n into 2 pi plus pi. So which should be equal to minus 5x plus 8t. Okay, now you go on substitute these n values, then I will get different values of x at a time of t is equal to 2 seconds. Clear, number? Because waves, they are traveling continuously, no? So at different points waves should have interfered constructively and destructively. So therefore after a time of 2 seconds, okay, so now let us see this calculation here. Okay, ma? So after it, so let us see how these waves will interfere. Okay, ma? So when I take n is equal to 0, then I will get x value at which destructive interference is happening. Similarly, when it's equal to 1, then I will get x2, the second distance where I am getting destructive interference. Similarly, when n is equal to 3, I will get x3, that is the position where I am getting third destructive interference. Are you able to understand now? So you can go on calculating the respective destructive interference distances from the point of reference. Okay, ma? So just substitute n value 0, n value 1, n value 3, continuously you will get positions of destructive interference. Now at n is equal to 0, therefore I can write pi is equals to minus 5x plus 8t, no, ma? So and time is already given here, so it is minus 5x plus 8 into 2. Time is already given as 2 seconds. So substitute here 8 value is 2. Clear, number? So here all the values we have, just x value we don't have. So just to calculate the x value from this one. So that is my required answer. Okay. So if I calculate x value, that is the position, that is the minimum position from the origin or from the reference where I am getting destructive interference. Okay, ma? So therefore let us see, similarly you can calculate for n is equal to 1 and n is equal to 3. So let us see what is the answer he gave. So here all the quantities are known quantities, no, ma? So therefore I will get x1 value to be equal to, let us see, so it is equals to 0.0584 centimeter. So this is the distance from the reference where we are getting destructive interference. Okay, ma? Similarly, for different values of n is equal to 1 and n is equal to 3, we get a different values of destructive interference. Okay, ma? So let us see this question here. So how far does the sound travel in air when a tuning fork of frequency 256 Hz makes 64 vibrations? Velocity of sound in air is given as 320 meter per second. Okay, ma? So what is meant by 256 vibrations? It means frequency 256 means this source is making 256 waves per 1 second. That is the meaning of this one, no? It means in a time of 1 second, this tuning fork can oscillate 256 times in 1 second. And in that 1 second, velocity of sound is some 320 meter per second. It means in that 1 second, sound should travel a distance of 320 meters. That is the meaning of this one, no? So therefore, by the time it completes 256 waves, sound should travel by a distance of 320. But we are supposed to calculate only after 64 vibrations only. So in 64 vibrations, sound cannot travel 320 meters, no? Because it can travel 320 meters only if it completes 256 vibrations. So therefore, in just 64 vibrations, how can I do? I can take the fraction of vibrations multiplied by total distance that a sound can travel in 1 second. So therefore, 64 divided by 256 Okay, ma? 64 divided by 256, what I will get? I will get fractional waves. Fraction multiplied by the distance it can travel, I will get fractional distance. Clear, na, ma? So therefore 64 ones are 64 fours are 4 ones are 4 eights are 32. Clear, na, ma? So therefore I can say 80 meters is my answer. Clear, na, ma? So by the time it completes 256 vibrations, sound should travel 320 meters. But only 64 vibrations are there, no? So in 64 vibrations, sound can travel only 80 meters. That's our answer.